Hi again. This is my pleasure to introduce the new speaker, which is Franck MAMALET. Franck is a technical leader in artificial intelligence at IRT Saint-Exupéry. He will talk about the main results and activities of the Certification Working Group on the DEEL project. Once again, feel free to ask questions on the chat. Franck, the floor is yours.
Okay, good afternoon and good morning, everyone. Thanks, Gregory, for the introduction, and thanks for giving me the opportunity to share the outputs of the DEEL French Mission Certification or AI Certification Workgroup. Okay, you know me, but even if I'm the speaker today, this presentation is about a work group of about 20 people called Mission Certification, and you will see some of them also in the following table ronde. To let you know where this work group stands, in DEEL Project in France, we've got, as you have seen with Melanie and Sébastien presentation, the main workforce, which is called a core team, composed of researchers, data scientists, industrial AI experts, and the certification work group was built around this core team to address certification issues. And this work group is composed of experts of safety critical embedded systems, certification experts, and also, of course, AI experts. But we are not the only work group, and mission certification members are also involved in several other groups or projects, just like ROCAE WG114 or CERTIF or AVSI. So you can see that we have 11 partners in 4 safety critical domains: aeronautics, railway, automotive, and energy. We are organizing 2 days workshop every month, face-to-face when it was possible since April 19. And the main objective of this work group are to share knowledge on certification and machine learning and between domains, to identify the main difficulties raised by the usage of ML in the safety critical system, to feed the core team with relevant scientific challenges for certification, and to end with, to provide elements of confidence for certification. Okay, I will start by presenting the first output of this work group, which is the result of more than 1 year of workshops, and which we call the white paper on machine learning and certified system. This white paper is now publicly available since March this year, and you can find it on arXiv or HAL or following this QR code. So the first thing that we saw that given the fact that existing standards do not address ML-based products, like Guillaume told us this morning, the main question was, what are the certification objectives for these ML products? We decided to identify and to work on what we call high-level properties, that is, properties that, if possessed, have a positive impact on the capability to certify the product. We have in the work group some experts that had participated to the overarching property working group, but we were convinced that these properties, the intent, correctness, inequity, the 3 properties defined by this working group, was at too high level, and we need to find something in between for machine learning. So we proposed the high-level properties, HLPs, and you can see a list of 11 main properties here. Given these objective, given this HLPs, the main objective was to point out main challenges to fulfill these certification objectives. And also, as you can see, we have restricted the study to offline supervised learning, which is the first step. Even if other kind of learning is interesting, it was the first step, so we start with this. For this, we conducted several types of analysis. The first one, which we call process analysis, was to find where engineering choices can have an impact on the compliance with the HLPs, where some fault can be introduced. We also try to do some similarity analysis, finding systems that are already certified and that can share similar challenges with the machine learning. So, for instance, we were interested by Kalman filter certifications. And then the last one was backward analysis. That means trying to see if inside the ML techniques, there are some techniques that allow an easier demonstration of HLPs. So all of this analysis bring us to 7 main challenges that we have decided to explore more deeply. Some of them are directly linked to HLPs, but some of them are not. I will give you some key points and results for each of these main challenges in the following. Okay, let's start by the first one, probabilistic assessment. So the objectives was to see if we can, how to develop safety and analysis on system, including ML applications. The question was, third question was, does the performance of 99% for ML items is sufficient for safety critical product? Probably not. And is a clean process can be also enough to be embedded in a safety critical product? This also probably not. So we think that we need to soundly measure the uncertainties of the machine learning systems and make sound relationship with safety objectives allocated to the ML-based system. So you've got some example of challenges that we have written on the white paper, but I won't describe them. Okay, the next challenge is about resilience. So resilience is in the challenge when the efficiency and the robustness of the ML system is not enough, and where we need to introduce system level mitigation means in order to be compliant with the safety objectives. But machine learning system can raise also new challenges and difficulties for monitoring and redundancy. For instance, the question that can raise is, can we monitor ML-based system with another machine learning-based system? When dealing with dissimilar ML system, how can we assess the dissimilarity between these systems? The next challenge is about specification. Specification, because ML is often used for complex tasks that are by nature hard to specify. So you can see the example of pedestrian detection, and this introduced some new difficulties in introducing such task in such ML system in a certified system. So we first foresee an increased importance of the iteration loops during the refinement of the specification. We also point out the difficulty of the traceability to requirements and wonder if training set can contain part of the specification of the machine learning system in the intended or unintended behavior. Okay, challenge 4 is about data quality and representativeness. So it's more classical and known challenge for machine learning. We found, and there exist several standards that describe different properties for data, but none of them are fully relevant for ML systems. And so, for instance, we point out the importance of representativeness and also of biases. Okay, next challenge is about explainability. So explainability, as we already discussed today, is an active research topic, and it can help the designer or facilitate the HMI or provide also maybe tools for investigation. But as you know, ML algorithms are more learning correlation, and which does not imply causation. So besides, explainability techniques are also known to be perfectible, and we emphasize on the, for instance, on the lack of metrics in the literature for this explainability challenge. Next challenge, this is also a well-known challenge for machine learning. I think you all know about adversarial example for neural network. And for this challenge, we emphasize, for instance, on the need for definition of robustness or definition of similarities, especially in high dimension like images, which is quite complicated if you want to evaluate the robustness of the machine learning system. The last challenge was about verifiability. So it's a challenge that encompasses the probability and testability HLPs. In probability, you've got the biconstruction probability, such as Lipschitz neural network, where you can get some interesting guarantees on the outputs, and but you have also the a posteriori probability, like the formal method that we already discussed today. In testability, of course, the code testing is still needed, but it's not enough, and we start thinking about a list of testing that can be done for the ML system, like robustness testing, performance testing, or worst case testing. Okay, so this white paper, sorry, was a global and top-down approach. And from 2020, the Mission Certification Workgroup decided to conduct thematic activities in a more bottom-up approach, relying on use cases to focus on special challenges that we identify. So I will give some examples of activities that we are working on, and also some results that we have published this year. The first use case, the first activities was about a use case which is called Acas-Xu. So Acas-Xu is an avoidance system for drones. And it's a well-known data set because it was the first that was used for formal verification of neural network. So the objective of this use case was to replace the lookup tables given by Acas-Xu by a set of neural networks. And to provide, the objective was to provide an assurance case that could give claims of the confidence that we have in this system. The team has proposed an hybrid architecture design, hybrid because it's relying on neural network for the main part of the process, and they add a safety net system which was based on the results of the formal method applied on the neural network. So the formal method gives you the zones where the neural network doesn't work, don't work, and so can take the decision in these zones. They also provide a simulation toolbox for this Acas-Xu system, and the assurance case trying to provide confidence evidence for this system. So the paper was accepted in SafeComp 21, and it will be in September, I think. And the next use case was about computer vision, and it was a recognition of railway traffic signals and the objective was to build a certification strategy. Of course, it's a wide subject, so the team concentrates first in the data quality and representativeness, given the lack of standards addressing the specificities of ML. They propose a set of documents that you have here: DDS, DRS, and DVP. The three documents which all require at least 3 types of experts that you've got on the right. This was presented last year at POSOC. And the second activities was about a testing approach for safety critical machine learning system, and hopefully it will be published soon, which propose 4 kinds of testing strategy and explore methods for testing and stopping criteria. The next activities is about probabilistic assessment. So it was in order to go further than what was presented during the white paper, the group analyzed the possible link with current safety practice, such as hardware certifications, but also we detail a list of ML estimator and several formulation of statistical guarantees that we can get, something like what Sébastien and Melanie presented you earlier for surrogate model, but in a larger way. And a list of source of uncertainty that we should take into account to make the link between the statistical guarantees and the safety estimation. Okay, this was last year, and this year, the work group started three new activities. The first one is not new, it's probabilistic assessment, but we want to go further on this point. The second is about optimization of neural network and implementation, and the certification counterpart. What does this imply for certification? And the last one is about machine learning monitoring in order to identify the properties to verify on the environment or on the model behavior, and what we can monitor, which techniques should we use, and does this help to get more confidence in the machine learning system. Here is the conclusion. So I presented you the working group on AI certification, mission certification. I think it's a fruitful collaboration between certification and AI expert, and also the core team in DEEL. We have active links with our groups and projects, so we are not doing the standards. We are just trying to provide information for these groups. I give you the information about the white paper in machine learning and certified system, and a list of 11 high-level properties, and the 7 main challenges and open question for AI and certification community. So I must think, yes, if you want any more information, you can contact the 2 co-animators of this, the 3 co-animators of this mission certification. And I thank you for your attention. I will be pleased to answer a question if we have time.
Thank you, Franck. Thank you very much for this very complete talk about certification work group in DEEL. There is one question. Is there a preprint for the Acas-Xu use case paper?
For the Acas-Xu, no, I think it's not published yet, but if you want, just contact me, and I think it's something that we can share, sure.
Okay, I have another question from Xavier. 7 main challenges and a number of sub-challenges have been identified in the white paper. Is there a plan to dig into all of these challenges all on the long term?
Okay, that's a good question. So obviously it's a question of workforce. Some of these challenges have already been tackled by the core team and by the mission certification. So we are trying in the core team and the mission certification to answer some of these challenges, but surely I think we won't be able to cover everything, but we think that all of these are challenges that need to have research on it, and feel free to go further on these points.
Yes, maybe I can add one question for you, Franck. Regarding this robustness challenge or high-level property, do you address all the kinds of robustness, or is it specific to adversarial attacks?
So in the white paper, we identify several problems. The adversarial attacks is quite the main point, at least the one that is the most known. But we also wonder about the worst case example, the one that that are not are not often seen, and how we can detect them, and So no, it's not only adversarial example, but there is also other topics on robustness in the white paper.
Okay, thank you, Franck. And one more maybe comment from my side, and maybe if you want to elaborate a little bit. Regarding the data representativeness, I think we already mentioned this today, but it's probably one of the most tricky points. My feeling is that it will be just like for the specification aspect, it could be some kind of iterative process in order to refine this data representativeness, using probably toolboxes with on explainability, on bias, and so on. Can you maybe elaborate a little bit on that?
Yes, for sure. The building a data set will not be done in time, and you will have loops between experiments and learning in order to see if you can cover some points, if you have biases also in the data set, and how you can either try to unbias the data set or correct your machine learning system to be able to be robust to this kind of problems.
Okay, I think it's more or less in the sense of one other question we had in the background. How do you certify the data set is complete or incomplete? You already give part of the answer.
Yeah, well, that's a good question also, but one point that I think that was in the white paper was, do we need representativeness for the training set or only for the test set? This is also an interesting question, because we know that we have this power to generalize with machine learning system, and maybe the most important data set is more the test set, the one on which you will assess the performance of the machine learning systems. And here you will need to get a representativeness coverage, and so the iterative points like in SOTIF, like what proposed the SOTIF norm or something like this.
Okay, thank you very much, Franck. I think we are at the end of this session. Thank you very much again, and
okay, thanks a lot.
To the next talk.
Yes, sure.
Which is a panel, by the way.
Yes. Bye-bye.
Bye-bye.